Hi, welcome to the BDP Project 1. The first use case in this project is identifying the common friends for any two individuals. Let's understand what this use case is exactly in first. Um, Coming to the input, what we are trying to do basically is we are trying to view the input um, with the spacings of tabs with each tab space. What this input indicates is like this is person 1, and here is the list of all the people, that is list of the friends that the person has. Basically in this input use case we are trying to consider 5 people A, B, C, D, E, where person A has B, C, D as friends, B has A, C, D, E, C has A, B, D, E, D has A, B, C, E, and E got B, C, D as his friends. So the output should be exactly like consider if A has B, C, D and B got A, C, D, E, then the output should be like A has C and D and B has C and D in common. So the output should look like A, B. The output should look this way. That is A hyphen B uh, and C comma D, where these two will be separated by a space, and A and B are the grouping that we are doing, and C and D are their mutual friends, that is mutual friends of A and B. So now let's come into the code. In this code, this is the class name of this one is Facebook mutual friends, where we have three methods here. One is this first one is mapper, and the second one is reducer, and the last one is the main method. So coming to the main method, here we are instantiating a configuration and we are assigning a job to the configuration, and we are setting the mapper, the main class, as well as the mapper class, and as well as the reducer class. We are setting the input and the output types, that is we are configuring it as text, and we are adding the input path, we are adding the output path. Now coming to the mapper part of it, so the first part is like the declarations. Here what we are doing is the whatever the data that is stored in the file, we are getting all the data into this total data. So this total this input is separated by a tab space. So we are using this \t. So now this array will have 5 values, because each will be separated by a tab space. So each array value will look like this. This is the complete set. So now this is to write the output. So basically if the output is um, so if the output is this one, this is going to be the key, and these are going to be the values. So what we are doing is to store the key part of it, to store the values part of it, we are using output values, and to store the key part, we are using the output keys. So in the first step what we are trying to do is we are trying to create two arrays. So let's see in the algorithm first. So what we are trying to do is like we are trying to create two arrays, array 1 and array 2. So since we are splitting the first part like A slash B C D, this is going to be the first value of our main array. We are splitting again this we are trying to take this one into our array 1, where our A will be our key value and BCD will be our values. Storing this will be stored in array 1 of 0 and array 1 of 1 simultaneously, and um, and so the so for that purpose we are instantiating this array 1. So in array 2 what will happen basically is we are trying to consider the next value by incrementing the k value. So we are considering array 2. So this friends 1 to store the friends of array 1 and to store the friends of array 2. Let's look into the code first. First one is, as I told you, like this will be the value that we are getting in the first of the total data, uh, in the first value of the total data. So this array 1 will be splitted with the help of this arrow mark. So now the key value will be our array 1 of 0, and all the friends will come into the friends of 1. When I say friends, this means BCD. This comes in friends of 1. So for every uh, for every friends of like each and every friend, we are trying to identify, um, we are trying to append it to the mapper out. So the first value, first the steps will be like mapper out is equal to B, then next it will be like mapper out is equal to B comma C, then the next it will be like mapper out is equal to B comma C comma B comma C comma D. Okay, so this will be the array 1. Now coming into the array 2, the same thing will happen in with array 2 also, but it will be considering the next element in the total data, that is B A C D E. Again this will be splitted as array 2 of 0. So B will be coming into array 2 of 0, and ACDE will be coming under friends 2. So what we are trying to do is we are trying to append this key values with the new key, that is B. So hence it will be coming as A hyphen B, and again we are appending to the friends 2, that is the friends of B, to the mapper out, so that we can get some output this way. So the final output of the mapper will be looking like a hyphen b in the key side, a hyphen b in the key side, and followed by all the values a hyphen b in the key side, and followed by this a a part as well as the b part that is coming in array 2 will be appended. So this will be the, so the final output of the mapper will look something like this, because this will repeat for all the values of I as well as all the values of k. So the final output of the mapper is this one. Then coming into the reducer part, our job, the job of the reducer is to identify the part of the intersection. So what it will do is like each and every value of the uh, input to the reducer will look like this, something like this. Now coming into this, we have to identify whether there is any repetition in these values. So if you see these values C and D are repeated one more time. So now what we'll understand is like the keys will be constant, that is already the keys are A B. So it will be constant. Now when coming into the values, we have to just identify the common values. Here it is CD. So the output, hence it will look like already there is AB in the key value. And now if you identify the common part, that is CD, here the output will look like CD, which is the expected output. So for that, what we have done is we have used something like okay, we have loaded all the friends into this array. That is all the value that is coming in into this array. So when we are trying to extract each and every part of this array, if so we are trying to compare if this array of I equal to array of k. So when c becomes equal to c, this will come inside and it will be getting appended to this reducer out. Then when d comes inside, what will happen is this goes into the else part and again appends with c. So now what it will become is the key value becomes the key as it is, so a hyphen b, and now the reducer out will be like c comma d, so it will give us a hyphen b and c comma d. Now let's run this program. First we'll make sure there is no output inside this, so there is an output. So first we have to delete that output. So now we have to run this program. So I have, and now I am refreshing. It is taking some time. Okay, it's done now. So the output will look something like this. This is A, B, and it is C, D. Similarly, A and C have friends in common as B and D. A and D has friends as B and C. A, E, B, C, D, B, C, A, D, E, B, D, A, C, A, and so on. In this way, we can identify the common friends. Now, what I have done is I have visualized the same in Cloudera View browser. For that, the steps are something like this. So first, in this case, I have created a folder called project1 in the View browser. Again, I have loaded this input text that is the input that I have given. Mm, I have given here the same thing I have loaded there. Then I have executed the jar. The jar that I have taken is Facebook friends jar. I'll Facebook friends jar. So this this one so I am executing this command to execute the jar file. This command explains something like this is Hadoop and this is the type jar and the name of the jar is this one and the name of the class is Facebook mutual friends. The name of the class uh, is the name of the class is this one, the name of the file as well as the name of the class here. Okay, then this is the path of the input and this is the path of the output. So after executing, this is success, and in Hue browser we can see this output. So inside the Cloudera project1, this is the input file that I am loading into it, the same input file that you have already seen in the Eclipse. Now inside the project1, this is the output file that is generated. So inside this we have all the outputs that you have already seen in the Eclipse. And thank you.
Hello everyone and welcome. My name is Zachary, class ID of 25. Today I'm representing the team number 3, and in this video I will show you our submissions for task number 2 in project-based exam number 1. So in this task we should start working on this dataset. This is a YouTube dataset that has many columns, and we are using this dataset for our big data programming class. So in this dataset they have many columns available here, but what we need to focus on is this column which has the IDs of those videos. This column, it's the 4th, and it contains the categories of those videos, and the 7th and the 8th, and they are possessing the ratings. So this is the rating of the video and how many raters on this video. With no further ado, let us see the code. So I'm using Ubuntu 20 on Hadoop 3.2.1, and on top of that we are using IntelliJ IDE to develop this Hadoop job. So for the first task we should look for the top 5 categories, or the top 5 categories with maximum number of videos uploaded. So this is the first method, which is the map method. So in the map method we are taking the dataset line by line, creating a new string list, and then taking a delimiter of tab, and then checking if our string has a length of more than 5. This is basically a small if condition to see if we have anything wrong in the dataset, because not every row is represented properly. So as you can see here, this row is fatal, as well as this one, as well as this one. After that we are just writing the targeted column, which is the category, and then the iteratable. For the reduce method we are making a variable called sum, iterate over the categories or the targeted columns to sum up everything, or every value of that targeted column, and then writing in the context the column and the calculated value. So let us see the configuration before running the code. So as you can see here, this is the top category arguments. We are taking the input from the input folder, and then the output folder, which will contain later on the results of this job. So let us run the code. After running the code, you will see that this folder has been changed now, and these are the results. These are correct, but unfortunately not well formatted. So what we did is that we made this Python code to represent the values of this file right here to CSV file to be well presented. It's basically to reformat the file. So after running the code, we will see a new file in the output folder called the same name with CSV at the end, and it's well formatted this time. So as you can see here, these are the inputs and these are the outputs, since we are using the shell to read the top 5 categories. So these are the last results after running the Python code. So if we run this folder in the terminal and then calling the sort command in Linux, we will take arguments of numerical reverse of column number 2 and then the name of the file, and we are just calling the top 5 results of the head of the file. So if you run this code, you will see the results. We have the entertainment with 911 videos, music, next, comedy, people and blogs, and news and politics. For the second task, we should look for the top 10 rated videos on YouTube based on this dataset. So for this task, this is the map method. The first lines are kind of familiar. After that, we will make a small if condition to check if this list has a length of +7 columns in the dataset to read the values, and then taking the column of video ID of the first one and then check if the 7th column in the dataset matches this expression. This is basically to check if the column itself represents a floating value. Lastly, we'll make a new float that holds this column, and then we will set the value of rating of this value. As you can see here, this is what we will write in the context, the video ID and the rating. In the reduce method, we will take a variable called sum to contains the total number of the ratings, or the total number of ratings on those videos, and then another value which will hold the number of values. We will take those two to iterate over the dataset we have, or the map job we just run, and then make the value of sum equals to the sum itself divided by the number of values. This is to calculate the average. Finally, we will write in the dataset the key which possesses the ID of the video and the sum. This represents the total ratings of this video. This is the main method which contains the configuration of the job. Before running the job, let us see the configuration in IntelliJ IDE. So as you can see here, we passed the output number 2 as a folder of the output, and let us see the code running. So after running the code, these are the results. These are the IDs of the videos in the first column, and these are the sum of those ratings available in the second column. If we run this folder on the terminal, we can call the sort command on Linux on this file, which is the result of the last job, taking the head of 10, which is what required in the statement number 2 to get the top 10 categories. The videos, the rated videos. Of course, the second column, which possesses the sum of the ratings, and this is basically numerically reversed. So as you can see here, these are the top videos available in this dataset. These are the IDs, and these are the ratings. I believe this is it. Thank you so much for watching, and you will find more in our report on Wiki. Thank you and have a nice one.
Hi all. Today I'm here to explain the project. In the project, I have taken task 3, which is Hive use case. For that, I have chosen superhero dataset, and I have created 2 tables. Because in the datasets we have 2 CSV files. One is hero information, as you can see. Superheroes dataset, there are 2 CSV files, heroes information.csv and superhero power CSV. So I have created 2 tables, in which one table has the information of heroes information, and the second table has superhero powers information. Firstly, I will show the screenshots of creation table, because as columns are very big, as I've created table, I have lost the command prompt of the first table. So I'll just show the screenshot for that. I have created a first table called superheroes with columns ID, name, gender, eye color, race, hair color, with ID as int, name as string, gender as string, etc. And next, I have loaded my data, that is heroes information.csv file, into table called superheroes, and then we have to check whether our data is stored into our table or not. So for that, you can just give select star from superheroes, and just you can give enter. So you can get this. As the data is very big, you will lose the command prompt. So I have shown you a screenshot for the first table creation. Later then, I have shown you 2 CSV files, right? So for using second CSV file, I have created a table called superheroes power data with all the respective columns as string. and then I have loaded superpower CSV file into my table called superheroes power dataset. I'm just checking whether everything is being loaded or not by giving select star from the table, and I have just given limit 10 because in the previous command prompt we could not see the command, so I have just given here limit 10 so that you can see everything here. As you can see, data is loaded. Now if we don't give limit, all of these are displayed here. Next, we'll go into our queries. First query, what I have done is I have done a query to get the total weight of heroes whose height is above 100. So I am just selecting weight from the superheroes table and hero's height whose height is greater than 100. I want total weight, so I am just giving sum of weight from here. As you can see, we have got, this is the output. To get the total weight of the heroes whose height is above 100. So here we are using where height is greater than 100. So whoever height is greater than 100, those heroes' weight is summed up and output is given here. And next query is to get name and height of the heroes order by height. Like I have given descending order and limit 10. So you can see we have got 10 number of heroes names with height in descending order. I am just selecting name and height from superheroes table. This is my table name. I am ordering that by height, that is in descending order, and I have given limit 10 because so many will be displayed. So I have got this 10 names with respective their heights and in descending order. Next, third query is I am just concatenating the gender and height of the heroes whose hair color is in the CSV file who has no hair color. I am just concatenating those gender and height of those heroes. I am just using concatenate function of gender and height from the superheroes table whose hair color has no hair. As you can see, this is the gender and this is the height. As I have not given any limit, 75 rows has been displayed. Next, our fourth query is in the data set, if the hero's gender is female, I am just getting the average height of those heroes whose gender is female. So for that, I am just selecting height from the superheroes table whose gender is female, and I am calculating the average height. So I have given average of height from superheroes table where gender is female. You can see we have got the average height of the heroes whose gender is female. Next query is we are just writing a query to print the gender. We are selecting gender column from the superheroes table, and when gender equal to male, then give as male gender, else female gender. I have given limit 100. If gender is male, it is given male gender, otherwise female. This query is just printing heroes whose height is between 150 and 160. Firstly, I have selected 140 and 150. I could get only 2 columns, so I have given 150 and 160. This is just selecting name from the superheroes table whose height is between 150 and 160. You can see we got these names whose height is above, whose height is between 150 and 160. Next, query number 7. In query number 7, we are just, as we have created 2 tables, in query number 7, we are just using a join query to join these 2 tables. One table is superheroes and other table is superheroes power data, and just printing the selected columns from the tables. as you can see, as I have selected name hair color from superheroes table and I have named it as A, and from superheroes power data I have selected hero names and energy absorption, and I am just printing those columns. As you can see, this if there is hair color, it will display energy absorption true and hero names. In the 8th query, I am just creating a table, and then I am storing, I'm selecting a cell. I'm just selecting columns from both the tables into a newly created table. Actually, I'm creating a new table using those two tables which I've created before, and then I am just storing those columns into a newly created table. I've just created a table called table joint with some of the columns from both the tables. Hero name is from the second table, eye color is from the first table, agility is from the second table, durability is from the second table. That is superheroes power data. And then I'm creating a table called table joint, and then inserting some values, and then I'm displaying those from this table. As you can see, table has been created, and those are been displayed from the newly created table. This is my newly created table called table joint. Next query is getting the count of the heroes whose height is between 170 and 200 and weight is between 50 and 100. So I am just selecting count. I'm just getting the count. So I am giving ID from superheroes table where height is between 170 and 200 and weight is between 50 and 100. So as you can see, I have got 256. Next, last query is I am just getting the name of the heroes in which publisher there is a column called publisher in the there is a column called publisher in which publisher is comics. I am just displaying the name of those heroes. I am just selecting name from the superheroes table where publisher is a column like comics. I am just giving limit 20 so that I have got all these names. Thank you.
Hi, this video is recording fourth part in project-based exam PDP, which is about to run queries in Solr. So what Solr is, it is an open source platform for open source search platform. For it works for several websites because it can index and search multiple sites and return all the recommendations for searched content. It hits the Solr and returns the recommended search content. Start by creating configuring, create the schema and configure it. Start for the download your data set initially. First you have to generate a, let it be AB. I'm generating it this way. And next you have to edit the schema. I'll show you how to edit the schema. Schema page will be displayed here, and you have to go to the data set. So consider this data set. Now we have 9 indices here, 1, 2, 3 and so on. We have 10 indices here. So you have to go to the schema configuration page, schema page, and configure it as follows. Make all 10, copy paste it for the 10 times, remove all the required columns here, and in the place remove all the required leave it for the first one and remove all the required columns here. We don't require it. And now in the place of ID, first ID, go for the first index. We have name dot name underscore I. So copy paste here. In the second one, we have gender underscore I, and now copy paste here. Similarly for all the 10 indices. Now we have to go. Now we have to change the unique ID with which the dataset actually gets recognized. So first index is name, and check for the unique, and change ID here this way, and save the configuration page. And now after schema, we have to now after configuration, we have to create an directory in the Solr, for which we have to use this command. This way, it takes about a minute to run, and it gets uploaded, and you have it gets created, and we have to upload it. Here we have to upload it this way. If we click enter, schema, this data set gets stored here, and you will be it will be seen. The data set will be seen in the our Solr page. Now, now we have to run the queries. So I have all the commands already here. First first query is about keyword matching. In keyword matching, it searches for the particular keyword using keyword matching. It only gives gives the content of that where the particular keyword actually lies in. So I've copied this. I have to run a query, so select query, paste it here. So first I'm searching for in the index I color, I'm searching for a keyword blue. So now it returns all the content with the keyword blue in I color with all blues. Next, for the AND operation, with AND function, keyword matching with AND function. Now it searches for no hair in a hair color and DC Comics in publisher simultaneously, and displays the combo. I have to copy this. Run the query. Now I'll get all the outputs with no hair and DC comments from the given dataset. Next, with this OR operand. Now it searches for either of these two statements: no hair color, no hair in hair color, and the DC Comics in the publisher, or blue in eye color. There it is a simultaneous function. Here it will be an either function. Functionality will be either. So DC Comics, no hair color, and blue will get outputs regarding with this. Next is not in here in this query. I'll be searching for angel in name index with no black hair color. So we have multiple with. So this is how it returns. There is a if we go for the data set and check with the name of angel, we have several, and with no hair color. it returns something with no hair color as follows. Next, next is wildcard. And where wildcard searches is a string search for this word yellow in index eye color. In the eye color field, it returns everything with eye color yellow. So yeah. Next is proximity. Proximity, where it searches for this keyword in the index and under the proximity range. It supports the search for a specific distance only. So it gives in the proximity range now with all blondes. Next is a Boolean. This Boolean it actually contains multiple clauses. So here precedence comes into existence. It works according to the precedence. These parentheses are for precedence. It's search for okay. Here this I have worked it on a different data set. Let me change to the superheroes query. Execute the query. So I'll be working into according to the parentheses. I'll be getting all the agility containing true and lantha and the lantha powering containing true. Next is boosted. In boost query, in this operand here makes it a boost query. The boost is multiplied into the normal score for the clause and will affect its importance relatively, as compared to the other clauses. So in the dimensional awareness, I'll get all the true thing. I'll be getting dimensional awareness as true. The data containing dimensional awareness as true into 10. Next is a range. Range actually selects documents between the lower and upper limit and gives us the output containing in that particular range. In this syntax, this is a lower limit, and with which here I have given this asterisk, which means this syntax actually means to display the weights that are greater than 95.0, and there is no limit for this here. to go for a different data set. Go to the query, write your query, execute. So I'll be getting the weight with greater than or equal to 95. I mean 95 and above, and you won't get anything under 95. So yeah, as follows. Next one is face it. Gives the data with a particular field. So the query run will be a bit different. Select facet, write your facet query, have to select the index, the field. So now it displays everything that comes under skin color. So in the data set we have different skin colors. The data set heroes. Skin color we have different here, gray, brown, black and all. So the output will be displayed with different skin colors. And if I have changed this change the field, it gives everything that comes under that index. Let it be height. I'll be copying this here. Run the query, so I have to get everything under her. If there is any prefix, the displayed output will be starting with that specific prefix. For height we have nothing, so I'll be getting everything that comes under height. Here, this way I have executed all the 10 queries, actually 11 queries, with different possible queries, different kinds of queries that we can write in Solr. Yeah, that's all for the video. Thank you. And the execution time is actually no mean. I have executed every individual query here in this video. I've got instant outputs without waiting within no mean time. That's all for the video. Thank you.